Hello, in this video we're going to look at a question putting our new skills with moment of inertia into action. So we've got a circular flywheel, radius 0.25 meters, freely rotating with an angular speed of 10 radians per second, about a fixed axis through its center and perpendicular to the plane. Right, so we've got a disc which is rotating about this axis, which is going through the center of it. It's got a radius of 0.25 meters. It's initially going at 10. That's our omega equals 10 radians per second. Moment of inertia of the flywheel about this axis is I kilogram meter squared. Okay, so that's I. All right, so it hasn't told us that it is uniform. So we can't use our standard, we don't know what I is. We can't use here's the moment of inertia of a disk, because it hasn't told us that it's a uniform flywheel. Particle of mass 0.6 kilogram, initially held at rest, sticks to a point on the circumference of the flywheel. The angular speed of the flywheel and the particle immediately after this happens is 8 radians per second. Okay, right, so we're sticking something on the edge, which is 0.6 kilograms, and we are then that is going to reduce, it's going that way, and looking at the arrow before, reduce the angular velocity down to 8 radians per second. Right, so we've got a conservation of angular momentum question going on here. So we want to let everyone know that we're doing conservation of angular momentum. So let's note that down at the start. Our angular momentum beforehand, remember this is all I omega. So we don't have the little object moving at the start because that's initially at rest. So before we're just getting 10, our angular velocity, multiplied by the moment of inertia. That's our initial angular momentum. Then afterwards, we've now got 8I plus the angular momentum of the object that sat here. So we know it's I omega. So what is the I of this? What is the moment of inertia of this object? So think back to our definition of moment of inertia, when we were summing it up for things like disks, but we're summing up mr squared. So this is our this is what we need. This is our rotational mass that we've got, our angular mass. So we need to do 8 multiplied by all of this. So that's 8 multiplied by m, which is 3/5, multiplied by a quarter squared, 1/16. So this is all we've got to solve in order to get what I is. So we've got 2 lots of I is equal to all of that. So we can just say that I is going to be equal to 4 divided by 16. So that's a quarter. A quarter of 3/5 is 3/20. So that is our I, or 0.15 if you want to write it that way. Just put the units in of kilogram meter squared. So pretty straightforward. I mean, people get scared about this stuff because they haven't seen it before. But this is more or less exactly the same as what we've done on conservation of linear momentum. The only thing is remembering this bit, that we've got this way of working out moment of inertia for a single particle, and we're just building that in to all of the usual sort of equations that we're using. So yeah, pretty straightforward. So don't get worried about using moment of inertia.